So in this video, we are going to solve some questions under limits. And this is the first question I have on the screen here, which says that we should evaluate the limit of the expression tan inverse of 1 over x. Okay, so we have to evaluate the limit of this expression here. Okay, so how are you going to do that? Okay, so the easiest way for us to do this is to evaluate the limit for this expression from both sides. And you know, when the limits from both sides are equal, then that means the limits actually exist and you get a value. But if the limits from both sides are different, then that will tell us that the limit doesn't exist. So what you are going to do here is that you've been given that we should find the limit of this function as the value of x approaches 0. But you know, when you put 0 there directly, you get an undetermined answer, so you can't put 0 there directly, but you can put numbers that are closer to 0. Okay, you can put numbers that are closer to 0 there. So for us to be able to evaluate this limit, you are going to find the limit from both sides. So that be as the limit, that's the limit as x approaches 0 from the negative side, and then the limit as x approaches 0 from the positive side. Okay, so in this case, you're going to take numbers that are lesser than 0 but are closer to 0, and then numbers that are bigger than 0 but are closer to 0. So these are the numbers that I'm going to use. You can take any value that is very close to 0, okay, but it shouldn't be 0. Okay, so in this case, on the left side, I'm going to use negative 0.001, and then from there I'll use negative 0.01. You can test values as many as you want. Okay, I'll use minus 0.1, and then here too I'll use 0.001, and then I'll use 0.01, and then here also I'll use what 0.1. Okay, so what you are going to do is that you are going to point each of these figures here. You are going to put each of these figures in place of what x, and then find the tan inverse of that. That will be the tan inverse of what 1 over each of these values here. So first of all, I'll do tan inverse of 1 over negative 0.001, and then let's see what we get. That gave me minus 1.569. so let me write down here. So minus 1.569. okay, then let's do same for this side also. So that's positive 0.001, so that gave me a value of 1.569. okay, so this is what I got for this side also. You can test for the remaining values also. So that's tan inverse of negative 0.01, so that also gave me minus 1.569. let's do same for the positive side also. That also gave me 1.569. okay, so let's do for the last value also. That's the limit for negative 0.1. okay, so that gave me minus 1.47. let's do for the positive side also. That also gave me 1.47. okay, so you see that what all these values here, they are a bit constant here. You see you have negative 1.56 here. This side you see 0.1 is a little bit closer to 0. That's why you got the value to be a bit different from this one, but they are almost the same here, same as this side here. But the difference is that the limit as x approaches 0 from the left side is negative, and then the limit as x approaches 0 from the right side is what is positive. So you see that what the two limits are not the same, so therefore we see that what the limit does not exist. So this will be our answer. Okay, so with this question also, we've been asked to evaluate the limit for this expression as x approaches infinity. Okay, so let's look at how you're going to do that. So I'm going to apply L'Hopital's rule here, which says that when you have situations like this, we can find the derivative of the numerator and then find the derivative of what of the denominator. This is because infinity is not a value. Okay, you don't know the value for infinity, so you can't put it here. But we still have to evaluate the limit of this expression here. So for that matter, that's why we have to use the L'Hopital's rule. So let's go ahead and then look at how it will be. So that will be the limit as x approaches infinity. Okay, x as x approaches infinity for 2x minus 3 multiplied by 3x plus 5. Okay, or multiplied by 4x minus 5. Okay, so all this divided by 3x squared, 3x cubed, sorry, 3x cubed plus x minus 1. Okay, so you have to evaluate the limit for this. So what you're going to do is that you're applying L'Hopital's rule. So before you continue, let's expand the bracket that you have at the top there. So that'll be, I'm going to expand it separately here. So let's see what will happen here. So first, I'll take these two brackets here, this one and this one. Then later I'll come and multiply this one also in addition. So let's do this. So this will be 2x multiplied 3x plus 5. That's 3x plus 5. Okay, minus 3 multiplying 3x plus 5. Okay, so let's see what will happen there. So 2x times 3x will give me 6x squared. This will give me 6x squared. Okay, plus 15, sorry, 2x times 5, that will be plus 10x. Okay, minus 9x. This will give, and then minus 3 times 5 will be minus 15. Okay, so now let's simplify this. So this will give me 6x squared plus 10x minus 9. That will be x. That will be 6x squared plus x minus 15. Okay, so after I've gotten this, then now can I multiply by 4x minus 5 here. So now let's do that one also. Okay, so that will give me, I'm multiplying 4x minus 5 with this, so that will be 4x multiplying 6x squared plus x minus 15. Okay, minus 5 multiplying 6x squared plus x minus 15. Okay, let me get some space. Okay, minus 15. Okay, so this is what you have now. So let's go ahead and expand it. Okay, so 4x times 6x squared, that give me 24x cubed. That's 24x cubed. Okay, plus 4x times x here, so that give me 4x squared. Okay, plus 4x squared. Okay, then minus 4x times, okay, 4x times minus 15, that's 4 times minus 15, that give me minus 60x. Okay, then minus 5 times 6x squared, so minus 5 times 6x squared, that'll give me minus 30x squared. Minus 30x squared. Okay, minus 5x minus 5x, and then minus 5 times minus 15, that give me 75. So that's plus 75, plus 75. Okay, so that's what we have now. So now let's see if we can simplify this. Let's see if we can simplify this. So this is the only one you have here. So this will give me 24x cubed. 24x cubed plus, we have 4x squared, and then minus 30x squared. So that give me minus 26x squared. Minus 26x squared. And then you have minus 60x, and then minus 5x. So that give me minus 65x. Minus 65x. This plus what? 75. Okay, so this is what you have now. So now you can come and substitute this value in place of what you have here. Okay, so now let's go ahead. Okay, so now you have the limit to be as this now becomes the limit as x approaches infinity. Okay, as x approaches infinity. So you are going to write this value here now. So that's 24x cubed. 24x cubed minus 26x squared. 26x squared minus 65x minus 65x plus 75. Okay, so all this divided by 3x cubed. That's 3x cubed plus x minus 1. So this is what you have now. So now that we have this, we can go ahead and then apply the L'Hopital rule by finding the derivative of what you have on top, and then also the derivative of what you have down here. So you are going to find the derivative of this. So that will be the derivative of this, and then also the derivative of this here. Okay, so d over dx, then d over dx. You are finding the derivative of both of them. Okay, so let's see what you get for the end. Okay, so this now give me the limit as x approaches infinity. Okay, so let's find the derivative of what you have on top here. So that will be the derivative of 24x cubed. That will be 24 times 3 x to the power 2. So 24 times 3, that's 72. So that give me 72x squared. Okay, minus 26 times 2. So that'll be 52 minus 52x. Okay, minus the derivative of 65x, that'll be minus 65. And then the derivative of 75 is 0 since it is a constant. So after doing this, let's come and find the derivative of what we have down. So that'll be 3 times 3. So that'll be 9x squared. So that's 9x squared plus the derivative of x, which is what? 1. So plus 1. And then minus the derivative of this one here, which is what? 0. So after doing this, we will have to find the derivative of it again so that we get our final answer. So let's go ahead and do that. Okay, so now this will give me the limit as x approaches infinity to be, and find the derivative of this again. So that will be 72 times 2x. So 72 times 2, that will be 144x. 144x. Okay, that's the derivative of this 72x squared here. Minus the derivative of minus 52x, that will be minus 52. And then the derivative of 65 will be 0 since it is a constant. So now let's find the derivative of what we have done. So that will be 9 times 2x. So that will be 18x. 18x. And the derivative of 1 will be 0 this time. Okay, so after you are done, you can go ahead and find for the derivative the last time, so that will be the limit as x approaches infinity. Let's find the derivative of 144x. That will be 144, and then the derivative of 52 will be 0, so divided by 18, and the derivative of 18 will also be what? 18. So at the end you have 144 divided by 18, and let's see what we get for that. 144 divided by 18, and that gave me a value of 8. That gave me a value of 8. So therefore our limit is 8. So therefore our limit is what? 8. So this will be our answer here. This will be our answer here.